Okay, let's take the time derivative of this expression over here. Now, d dt r of t with respect to the inertial frame x, y, z is equal t dt capital R of t with respect to the inertial frame, the blue one here, okay, plus partial derivative. This is not partial, a derivative, okay, ordinary derivative. Now of the vector rho, okay, with respect to x, y, and z. Now, this over here is the vector v with respect to x, y, and z, okay? And the translation, okay, point O, point O prime, R here changed with the time, you see? R changed with the time. So I'll put a dot here, okay? R dot. Okay, R dot is the derivative of the position vector O prime with respect to O, okay? And plus d dt. Now, it's very interesting. You see, when I wrote down this relationship here, okay? And I'll write down rho over here with respect to x, y, and z. And I will develop this separately, okay? There's a velocity, there's a translation velocity. So I have a body, and it rotates and translates, okay? Rotate and translate, okay? Here there is an x, okay, of rotation, okay? Rotation and translate. I'm analyzing just a particle of this rigid body, okay? That's at point P. Now, let's work with this term over here, okay? The total derivative with respect to t is equal. Now is a partial derivative, okay? Why partial derivative? Because the product x of t, small x, e1, both are function of time, okay? Then, first of all, let's take first the time derivative of x and y and z. So, I will write down partial of x with respect to t, okay, e1 plus, now I'll take the derivative of the coordinate y plus dy dt e2 plus dz dt e3. Look how it's very interesting, because this over here is assumed that E1, E2, and E3 are constant, okay? And I could write here, okay, the vector derivative of the coordinate, okay? Now, let's continue, okay? Now I'll remain x, y, and z fixed and take the derivative of the unit basis, okay? So x d(e1) dt plus y d(e2) dt plus z d e3 dt. See? Now, here, x, y, and z are assumed, partially fixed, and then I have the rotation over here. Now, it's quite clear, okay, from the previous lectures that this over here is the rotation times E1. And this is the rotation times E2. And this is the rotation times E3. Now, you see, I can insert x, y, and z inside here. Okay, no problem. So I could write that this, I'll roll down, okay? I'll roll down. This is x dot E1, okay? Y dot E2. What means that? What means that? Let's write down over here. So, you see, these are the component, the derivative of the component of vector rho, okay, partially fixed. So this is V. I will not use blue one because this will be confusing there, okay? Let's write the red color, okay? This is V with respect to x, y, and z. You see? Look, here I see the x, y, and t changing with time, okay? As if I have, for instance, no rotation, this part here, okay? Now this rotation, so I can write now, okay, d rho dt, that's right here. Derivative of rho with respect to the time. This is equal Vx yz, okay, so this term over here, plus now omega cross rho. Why cross rho? Because I take the x and I insert over here. I take y, I insert over here, and z here. So I'll have x e1, y e2, and z e3. This is rho, okay, over here. So then the rho of dt, okay, is the sum of a velocity of this particle as seen from O prime, plus the rotation, attention now, the rotation of the rotating system with respect to O. That's why sometimes I can use, okay, this is rotation with respect to O. Okay, O is over here, the inertial frame. Okay, and this is a vector rho. Now, from here, I get my V with respect to the inertial frame. It's quite clear and easy to see it. So, V, X, Y, and Z is equal the velocity of the translation, okay, this rotation, this translation, I'll write down R dot plus V X Y Z plus and don't forget that this vector, the omega vector, with respect to O, okay? That's over here. So this is a formula for a velocity of a particle, okay? The velocity of a particle in a rigid body which translating and rotating, okay, with respect to the inertial frame. X, Y, and Z, just to reinforce, okay, this is X, Y, and Z. And the blue one, okay, here. So, our next step, you see, it's better for me to give an example, just for you to understand this formulation. Okay, very simple example, okay?